135 world-class laboratory and engineering facilities, and 30 major active test stands capable of handling nearly any challenge. We cover 65 square miles of the Mojave Desert, giving us plenty of room to test advanced rocket propulsion technologies. There isn't a better place to do rocket science. The facilities at the Air Force Research Laboratory's Edwards Research Site are highly flexible and adaptive. They are used to characterize, test, and validate the ever-changing advancements in technology developments for the Air Force. Our research covers the full gamut of rocket science, tactical, ballistic missile, space access, and spacecraft propulsion. While being environmentally compliant and friendly, our operations are not adversely impacted by the local endangered species or encroachment as many other parts of the country. Numerous external customers have used our facilities, including NASA, Air Force Space Command, and various companies as part of their development and qualification programs for new systems. Our solid rocket capabilities cover the full spectrum, from gram quantity liquid and solid propellant development in our chemistry laboratory to full-scale liquid and solid propellant mixes at Area 130. Area 130 can also be used to conduct validation and verification of propellant formulations. We conduct subscale component development and testing of new technologies. Area 132 is capable of handling subscale 2-pound motors to full-scale motor test up to 1 million pounds thrust without thrust measurement, or up to 450,000 pounds with full 6-component thrust measurement. Pad 1 and 2 were modified and expanded in 2004 to handle larger motors such as the Atlas V strap-on booster. Even larger motors can be tested on a number of other stands, including Stand 1C, which was most recently modified to test the 1.6 million pound Thrust Titan IV solid rocket motor upgrade. The stand has a full 6-component thrust stand, and the enclosure enables testing at temperatures from 40 to 90 degrees Fahrenheit. Our liquid engine test stands were originally built for the Atlas and F1 engine development programs. Today, they are a key component to our technology development efforts. Stand 2A is a high-pressure facility with 10,000 psi lines. It is used for both component development and full-scale engine testing, and is currently being prepared for component and full engine testing under our hydrocarbon boost demo program. The stand was recently used to support Microcosm Incorporated and Lockheed Martin Company in their DARPA Falcon development efforts. Test stands 1A and 1D are full-scale engine test stands. They are used for technology and system development testing and are capable of handling engines up to 2 million pounds thrust. Stand 1A was most recently used by Boeing for their LOX Hydrogen Delta IV RS-68 engine development. Stand 1D is a comparable LOX hydrocarbon stand. Our liquid engine analysis and component evaluation capabilities are critical to understanding the underlying physics and phenomenon occurring in the chamber, injector, and other components. We can characterize fuel properties and cooling schemes using our highly modular single-element EC1 and high heat flux EC3 rigs. We are currently characterizing RP2 for use in highly reusable launch vehicle engines. Injector characterization and analysis is done in our high-pressure cold flow facility and our supercritical EC4 facility. These facilities have been instrumental in helping industry partners resolve issues with their proprietary chamber and injector designs. Rocket propulsion can be a hazardous business. We have the capability to fully characterize the hazards associated with the technologies we develop and support outside customers with analysis of their systems. Our analytical chemistry laboratory has all the tools necessary to assess propellant, fuel, and fluid purity, identify unknown components, and support our chemists in the synthesis of new compounds. We characterize the hazards for new propellant ingredients and formulations, as well as conduct numerous system-level tests. The results are used to verify system response and to satisfy DoD and Department of Transportation hazard classification. Altitude facilities are a critical part of our technology development capabilities. Our electric propulsion facility boasts 7 chambers capable of simulating space vacuum and conditions. We can measure thrust down to 10 to the -8 newtons. Our largest is our 10-foot by 32-foot duration chamber, which has been used for live testing of Hall effect thrusters up to 4.5 kilowatts of power. The 30-foot diameter SPEF chamber at Area 142 uses diffusion pumps and is capable of handling greater than 10 kilowatt high-power electric propulsion and multi-mode thrusters. Area 142 is also the site for our large altitude thrust chambers, capable of simulating 100,000-foot altitude and handling either liquid rocket engines or solid rocket motors up to 50,000 pounds thrust. The Navy Standard Missile Office has been conducting ongoing third-stage rocket motor development and production verification testing in B-cell since 1997. Smaller upper-stage thrusters are handled at Area 114. Cells A, D, and E can simulate 100,000-foot altitude, while Cell C can simulate space and is used for spacecraft chemical thruster development and testing. Cell B is a sea level stand handling thrusters up to 15,000 pounds thrust. The facility is capable of handling LOX hydrogen, hydrocarbon, and toxic bipropellant combinations. Most recently, the THAAD program tested thruster modifications at Area 114. The National Hover Test Facility is a national asset. The facility was designed and developed to provide integrated system testing for kinetic kill vehicles for current and future missile defense systems. Every kill vehicle in operation came through here. The facility provides a safe, controllable, recoverable, and heavily instrumented environment that can be quickly and cost-effectively tailored to the special needs of each KKV test. Most recently, we tested the largest kill vehicle ever under the Multiple Kill Vehicle Program for the Missile Defense Agency. 65 square miles of the Mojave Desert. Extensive, world-class resources and facilities at your disposal. There isn't a better place to do rocket propulsion research and development.